on Fridays. Even though in some of your schedule, I think for embedded systems students, you have classes on Friday. I'm not really controlling how things are done in the scheduling, in the official scheduling, but the official scheduling is the one which is on the modern computer architecture Blackboard. In the course information, there is a PDF which is telling you something about the course. And the structure is that I will give you lectures for some weeks, and then you will be going to the lab, and we are still working on fixing the last details on the lab. I'll let you know probably in 1 or 2 weeks from now exactly how the shop will be running. And about the reading assignments, it's kind of the same story. You will work in groups, and you will have probably around 1 month to finish the reading assignment. I will not give you the reading assignment now. It will happen again within maybe 2 weeks. Depends on how things are evolving. Now, most likely for the reading assignment, you will be working in groups of 3, because otherwise I'll be overwhelmed by reports, which I have to read, right? If you write them, I have to read them. Then, read Blackboard, no classes on Friday. I put announcements on Blackboard about no classes on Friday, and I still get emails, sorry I missed the class on Friday. Okay. Now, wanted to say something? No? Okay. No, you may say. Just back to a detail, because one of your colleagues asked me about this reservation station. This is not one word. This is a wider register, because I'm storing here, what? 2 registers, which are value operand 1 and value operand 2. Then those are 32-bit or 64-bit fields. Then I have to store the opcode. Some functional units may execute more than one instruction. And then I have to pass the opcode also to the functional unit. If the functional unit can do only one instruction, sending the opcode will make no sense, because I'm doing the classification in here. I put it here or here. It's already a class of instructions. And then I have also to put those fields, which are now telling me which is the source of the operand coming from reservation station I and reservation station J. In here, I will need as many bits as necessary in order to represent, I don't know, K values. Then if I have 8 reservation stations, each field will have 3 bits. Okay? Then this is not a standard register in the machine, it's a wider one. This is counterintuitive. The ordering here. Okay, now we also talk about write back. Then whenever values are available, they will be broadcasted on the bus, and then whoever needs that result will store it locally. Then in here, if more than one functional unit has a result available, we have a contention. But each cycle, one functional unit can broadcast the result. Then let's say I have in a certain moment in time, an addition result available and a multiplier result available. I can, let's say, implement different policies on how to do that. I can have arbitration on the bus. I can go for round robin. Then each and every cycle I'm giving, the floor to one unit to provide a. Then if I go for round robin, there is no arbitration, which means it's simple. However, I may ask for results, functional units, which have nothing to tell me, and I'm wasting cycles. Then essentially this is a bus which is arbitrated. Now, in here we have a simple but relevant example on how Tomasulo is solving the write after read. You see, I have two instructions, a multiplication and an addition. There is a dependency between multiplication and addition, in the sense that addition is writing in F1 and multiplication is using F1 as input. Now this is an artifact. It's not a real dependency. I'm not waiting for the result from the multiplication to do the addition. Now I have to be sure that I'm doing the business in a proper way. Now, from the point of view of the adder, I can put the addition in the reservation station 0, and I will say what to do. Add double, and add double from F4 and F5. F4 and F5 are available, or at least I don't see that there are any problems with them. Then I will put there the real values. Now, from the point of view of the multiplication, I do a floating point multiplication, and what I have is F2, it's known to me as being available, and F1 is coming from a load. I can see it, it's a previous thing. Then, and that load was not completed, because when I'm looking in the register file on F1, I see this one is not yet available, okay? And when I see it's not available, I'll say, okay, multiplication D and value will be in reservation station load, which you don't see here, but there is another reservation station on load, remember? Then the value, when I look at the multiplication, the value of F1 was not available, and it was said it will come from the load. And then I'm storing there, one will come from the load reservation station, the other one is a real value. Now, what you see is that if I look at registers, I see the following. F1 is tagged as it will receive the value from reservation station 0. It looks a bit strange, but it's not, because I don't really need to update F1 as a register after I already made the link with the multiplication which is using it. If I change the order of the instructions, of the scanning the instructions, things will look different. But then it's a different program. Then, because I'm taking the instructions in a sequential way, first I will solve the story for the multiplication, and which I'll say, you see, I need F1. F1, it's not available, and then I'll make the link to the load reservation station. And I also make a link to F1 and say, this will come from there. Yes?
Why do you do these links?
Which
What
links?
stage? You said you do a link, you look at the code and you see when you're going to use F1 again.
No,
when
you
decide
take,
whether or not
no,
you're gonna do it.
you scan the instructions in a sequential way.
Who does that?
The hardware which is doing the instruction scheduling, the one which is implementing Tomasulo algorithm.
So what, we're not seeing it.
No, this is hidden. This is part of the internal kitchen of the processor. As a user, you don't see that. It's not your business. You just send to the processor the code. And this is something which is happening internally. And the beauty of that is that it will speculate at maximum the parallelism in the code. Okay, then when I solve the first multiplication, then I put it in the reservation station 4. F1, as you see, it's coming from a load. The load is not completed yet, and then I'll put in the reservation station 4 that one of the operand will come from the load, and I also put on F1 that it will come from the load. Now I move to the next instruction, which is an add. And I move to that instruction, and then I see, you know, this is an addition, takes two operands which are available, and we put the result in F1. Because I already made the link between the load and the multiplication, nothing wrong will happen if I update now in F1 as the result coming from the addition, because that's the natural evolution of the program. Then, and now what I have is the situation, you know, that's my, it's like a snapshot in the execution. I have two instructions. Addition is ready for execution. Multiplication may or may not be ready for execution. Results are tagged to be utilized in the register files only because I don't see other instructions. If I have other instructions, you know, I may have different things. Now, what will happen is the following. If the load is completed, you know, after I process the multiplication and I went into addition, maybe meanwhile, the load is completed. If the load is completed, the result will be broadcast on the common bus. Reservation station 4 would see the result, got the value, and multiplication, it's ready for execution. The execution of the addition will be always available. Now, if the load is not completed, the addition can execute anyway and update the result, and the multiplication, whenever will be completed, will produce the result which will be stored in F3. Then I solve the read after write hazard, and you can see things can be done in a similar way for other hazards. Then instructions, you have to bear in mind that instructions are processed in sequential order. Then the loop. Okay. Now I was speaking about loop. When I say a loop, I actually mean a process. And in here, there is another process which we don't see. The one which is fetching instructions. The instructions are in the instruction memory. Somebody is bringing them into that instruction queue, which is a FIFO. It's a FIFO. Then I process them in order. That's one process. The other process is the one which is taking instructions from the FIFO and is spreading them to reservation stations with values, with reservation station tags and everything. And the third process is the execution process, which whenever an instruction is ready for execution will be pushed to the functional unit. The functional unit will produce result will be broadcasted. Then I have three processes which are independent. You know, this is a technique which you may know as divide and conquer, but that's the wrong name. You know why? It was invented by the Romans and is divide et impera. Actually, it's divide et impera et intellige. I know you don't like Latin. Then Romans were very good in doing that in politics and in war. We are using it in technology. In general, when we want to solve a problem, we split the problem in parts. We kill the small parts because we can. If we cannot, we split them again. And when we have the results for the parts, we do the integration of the solution. Okay? And most of the people in the community will call it divide and conquer. I prefer to call it divide et impera. It's also more intellectual, right? You know, Americans, they like to show up that they can speak foreign languages. You know, they like to use German words, French words, you know, like connaisseur, which they pronounce like connoisseur. We have an American here, but he's from Canada. Or we have some that I don't know. No offense meant, right? No, but you know, it's part of the show. Then you get a lesson about the Romans also. Actually, you know, they are very smart and effective. Still today in Europe, most of the main roads are built in the top of the old Roman roads. Then Via Romana. There are many Via Romanas, all of them were going to Rome, and there was Via Appia, Via Flaminia, and those interconnects in Europe are built in top of the old Roman roads. Now the question is, how come that when they were that good, how come that they went into decline and disintegration? Okay, that's a different story. Okay. That's essentially the story of Tomasulo. Today's processors essentially rely on that. They are, you know, a bit more complex. There are a bit more tricks here and there, but the basic concept is Tomasulo concept, which is summarized here. Then, and those are the main things. I can do register renaming in an explicit way, but what Tomasulo is doing, it's an implicit register renaming. I'm doing on the fly. Actually, I'm just using those register reservation stations like non-architecturally visible registers, but again,